Hello students. So we are going to discuss NCERT, questions on the exercise problems as well as the exemplar questions. So we want to cover almost all the questions of NCERT, which will help you to get thorough with that. Because what happens is, particularly when you are going for JEE or NEET, even for your board exam, this is going to be very useful. Conceptually, how to solve the problems of NCERT, which is considered as a base level. But let me tell you very important thing, that NCERT, although it's a base level, but it involves questions of very high level as well. It requires for us to be, interpret it properly and go inside the problem little deeply. Okay, so we are going to see this. Let us start with these questions, right? So what is the first question? In which of the following example of motion can the body be considered approximately point object? Now, this is a very important concept. When can we, consider the body as a point object? Remember, whenever you are studying the body as a point, means you are only studying the translation motion or linear motion. You are not studying the rotational effect of the body, because the whole body has to be treated as a point, and a point has only linear motion, although it may move in a curve. That curve may be a circular path, but the motion of the body has to be considered as a linear. It cannot be taken as a rotational, because for a point rotational effect is not there, right? Let us see that. So a railway carriage moving without jerk between stations. So railway, let us try to take with a proper diagram. So suppose, for example, that this is a railway track. I'm just showing a part of it. Okay, so if we can assume, let us say, any point on this body you take, any point on this body, the motion of any point on this body except the wheels, because there will be many points on the wheels which will be rotating, right? So you can ignore that motion. Let us consider the whole train. And of course they are saying that without going up and down, because if it goes up and down, the motion will not be just in a straight line. So all the points on this body can be said to have same motion. You take this point, right? You take this point. Let us name this point as 1.2. So when this system is going to move, let us say that this is going to move after some time. Let us say this entire structure is going to move. Okay, entire structure is going to move. It has moved here, let us say. So if it has moved here, you can note here that this point, this whole car has moved. So point 1 has moved some distance x. So point 2 also has moved the same distance x. This is a point to note that. So each point on this body is moving together simultaneously. There is no relative motion between any point, any one point with any other point respect to, right? That. So there is no relative motion between the points or among the points. There is no relative motion. So this kind of motion, when it happens, you can definitely treat the body as a point, because you can study any point on the body, right? This can be equivalent to study the entire body, right? This is what we can do. But note that here we cannot study any point on the wheel, because the wheel will be rotating also about its center, and wheel also is moving forward. So that is rolling motion. So if you involve the study of the wheels, any point on the wheel, that will not be same as any other points on the body of this train, right? So we can treat any point, or this whole train we can treat as a point except the points on the wheel, right? This is important point. Next, what is the next part? If you see, a monkey sitting on top of a man cycling smoothly on circular track. Now here, let us try to understand here. Rough diagram we can draw, right? So suppose there is a monkey like this, and a person is cycling. This is just a rough diagram. Okay, like this, a person is cycling. So here you can treat this monkey as a point, or even the bicycle can be treated as a point. But anyway, here you are studying the monkey is not moving here and there, he is not rotating his hand, or he is not doing anything. So this entire, this monkey, this structure can be taken as a point, although this will be going in a circle, so we can assume it like to be a point, right? We can assume it. Then let us go to the next. Spinning cricket ball that turns sharply on hitting the ground. So suppose there is a ball, cricket ball, which is spinning. Now if you study different points on that, it is rotating about the center of mass, right? So now let's understand this. For example, this is a ball, cricket ball. Okay, so many points will be there, and but this point is a special point which is called center or center of mass. And if you study any other points, if you study, then all other points will be rotating about the center of mass, as well as it is moving forward. Okay, so what happens is that you can treat this whole body. When you are studying, you can study the center of mass, that will have only translation motion. But if you are studying any other points on the body, then those points will be having a complex motion, right? So we cannot treat the entire ball as a point mass, but yes, the center of the ball can be treated as a point, and we can study, because center of motion will have only linear motion, right? So whole body can be assumed to be concentrated at the center, then we can just study center of mass. That is possible, right? Then next, a tumbling beaker that has slipped off the edge of a table. So tumbling beaker, again this is same like spinning. If you take a beaker like this, let us say there is a beaker and this has fallen, so from some table, then what is happening here, that again here there will be a point which will be center of mass, right? And that will have linear motion, but all other points will be rotating about center of mass, and they will also be moving forward. So that means you cannot treat the whole object as a point. Similarly, like the ball, you cannot treat the whole object as a point, but you can study the translation motion. If you have to study the translation motion of such bodies, you can just study the center of mass, which you will be studying later, right? So center of mass, but here the whole body cannot be treated as a point, right? Whole body can be treated as a point when all points on the body, have the same translational motion, right? For example, here, even in this case also, we cannot treat points on the wheel, because wheels are having, so strictly speaking, this whole train cannot be taken. But if you see the question, are they speaking about the train or carriage, railway carriage? Now here note clearly they are speaking of railway carriage. It is not including the wheels, definitely. Then you can definitely say that it is considered as a point, because if they say that rail without no, they have not mentioned that, that means there can be a confusion, that should we include the points on the wheels or not. Here they are excluding that point, so definitely they are considering this as a point mass, right? And monkey, definitely this monkey is considered as a point mass, right? And also note that monkey is sitting, he's sitting on that, right? He's not doing any other kind of motion. And here spinning of this you cannot treat as a point mass, right? And similarly this tumbler cannot be treated as a point mass. So these ideas which are very basic, very fundamental, should be thoroughly clear. If it is not clear now, there will be confusion later on. And that's what happens. Students, they don't pay attention to these small points, and later they have confusion. This is the main reason for developing confusions. They don't bring clarity in discussion. They don't discuss. There is no clear discussions. They just carry forward with the doubts. So it is very important that you should discuss these doubts with your teacher, with your mentors, to make things very very clear. Then only you can move forward with full clarity and go on solving problems, right? Let us start the next question. The position time xt graph for two children A and B returning from their school O to their homes P and Q. Right, you have seen such type of questions. So let us just see here the graph they have given here. So two children are there, two boys, right? Let us consider two balls, right? So they are going, their graphs are given, and they are saying that this point P represent what? This point P is representing here the home of the A. This child A, its home is P, and this point, x is equal to 0. This is xt graph, position time graph. So here this person is starting and he is going like this way. So where he will be reaching his home, that also you can think, you can draw that, right? If you extend this graph, it may come here and it may be reaching here. So A will be reaching here, TA. Similarly, you think of this also. You can think about this also. Think about this. This is the home of the second boy, second child. He will be reaching here. This will be TB. TATB is nothing but the time instant when they are reaching, right? And also note that this A has started here at time 0, and B has started here, let us say this is time t1. So B has started afterwards. These things you can see that B has started afterward, A has started before, and also you can see the slope of the graph. Slope of the position time graph gives velocity, so you can clearly see that this slope is larger, this slope is smaller, right? So this slope is larger means B is moving with faster speed, right? And A is moving slower. These things we can see. And also note that this home of P is near to this, right? So this distance OP from the school, this distance or this position, no, it is near to that, and Q is further away. So you can say that the home of B is further away, home of A is near. So these are the questions. Let us see what are the questions. A or B lives closer to the school. Who lives closer to the school? So definitely we can see here in this graph, P is the home of A and P is near to this O. So this A lives near, right? A, the home house of A is near to this school, and B is further because Q is further away, right? So here the answer will be A lives closer, right? A is living closer than B. Then A or B starts from the school earlier, then who starts earlier? So you can see in the graph that A has started itself earlier at time 0. So A has started earlier. A has started earlier. So A starts earlier, right, than B. Then what? A or B walks faster than, so faster means the speed which is higher speed. So you can see the slope of B is larger. So slope of B is larger means what? Larger slope means larger speed, right? So B is faster. B walks faster. B walks faster than A. Then A and B reach home at the same or different time. So we can see also clearly from the graph the time when they are reaching their home. The time T A and TB are not same. Time T A and TB are different. But in NCERT, they have given the same. As per the figure, you can clearly see that they are not same. If figure modifies, then it is possible that it will be same. For example, I will draw that figure also. Let's try to understand. Suppose this is the figure, right? A, and another figure for B. B has started here. I assume that it is the same time, so I will draw here the same time first. Okay, like this. Suppose if this is the graph, okay, then in that case it is possible because this is time graph and this is x position graph. Clear? And you can note here this point that they have reached their home. If this type of graph is there, definitely they are reaching at the same time. This time for A and time of B to reach here, that is going to be same. If this is the graph, maybe the publication that has happened, the graph has not printed out properly. They mean to say about this graph, right? But according to the graph that we have, we can clearly see that it is different, right? A and B overtakes on the road once or twice. So overtaking means at the same position, same position. So same position happens at what? So we can clearly see that they are at the same position only at one time. At one time they have the same x. So we can definitely say that they are only who overtake, that is also. So A is coming, and first A has started, B has not started, so B has to start and B has to overtake that. So B is going to overtake A, right, on the road once only, right. Let us go to the next question. Number 3. A woman starts from her home at 9 a.m., walks with a speed of 5 km per hour on a straight road up to her office, 2.5 km distance, right? Up to 5 p.m. she works and return home by an auto with a speed of 25 km per hour. Choose suitable skill and plot. So we have to plot the graph, but you should know while you are taking a graph sheet and plotting it, exact distances you cannot make, right? You have to choose certain skills. And according to convenience of plotting, you can choose that skill. So let us try that. We'll make a graph. Let us say that this is the xt graph, position time graph. Why do NCERT give such questions? So that you think of plotting the graph and trying to figure out some important things from the graph, some ideas from the graph, because they have got a lot of applications, right? So let's think about it. So woman starts from her 9. So let us say that the point which we take as time 0, you can take this time as 9 a.m. 9 9 a.m. 9.00, right? am morning. Okay, this I have taken. Time 0, walks with a speed of this on a straight road up to, so constant speed see going, constant speed. And so the slope of this straight line must be constant, right? So 5 kilometer per hour, let us try to draw that. So we can draw like this way, like this, okay. And she reaches here at this point. This is the office, right? This point, how much distance? 2.5 kilometers. So this must represent 2.5 kilometers. X can be taken in terms of kilometers, so 2.5 kilometers, right? Then when she will reach, so she is going with a speed of this, so how much time it will take? First figure out time. So time is equal to distance by speed, so 2.5 kilometer. Distance by speed is 5, right? So that means half an hour. Half an hour means what? 30 minutes. 30 minutes, correct? 30 minutes. So now when she will be reaching her office, this point, what will be the time? This time will be 9:30 a.m., right? 9:30 a.m. So this is the point when she has reached. Then what else? Stays at the office up to 5 p.m. Now this thing is that you should know that suppose you are drawing this scale. Now this scale is going to be very large, right? Why? Because this is half an hour only, right? And you have to show up to 5 p.m. So many hour difference. So what you can do is that you have to choose this scale properly on the graph. So half an hour scale you have to choose. Suppose you choose like 2 centimeters or 3 centimeter. Let's just say 3 centimeter. 3 centimeter represent 30 minutes, right? Each centimeter will represent 10 minutes. Each centimeter will represent 10 minutes. Now from here to there 5 a.m. This up to 5 a.m. you need to draw this graph. Sorry, 5 p.m. 5 p.m. you need to draw. So from 9:30 to 5 p.m., that is how many hours you can calculate. In 1 hour we have 60 minutes, and 10 minutes we are representing by 1 centimeter. So 1 hour you will be representing by 6 centimeter line. So you have to properly choose that, right? You can choose that. So then it will be coming here, right? It will be coming here like straight, right? After that, what happens? Return home by auto with a speed of, now while returning the speed is half, right? While, no, sorry, speed is more. 5 times speed has increased. That means while returning, she is in rush, so she is going with 5 times larger speed. Okay. Then what will happen? So you can just think about it. If this is 5 times larger, this is speed, same distance, right? 2.5, but 5 times larger it becomes. Then what will happen? It will get divided by 5, extra 5. So that means 6 minutes. In 6 minutes, you will be reaching here. So you need to draw this graph, right? You need to draw this like this straight line. And this you have to represent as 6 minute means what? You have to represent this as 5:06 p.m. That's all. Only thing is that now if you are choosing 1 centimeter as 10 minutes, then 6 minutes, how will you represent? So 6 minute you have to represent also. So maybe you can choose 1 centimeter as 6 minute, right? Because you have to choose the boxes in the graph, right? So properly you have to make some scales, right? So if you choose like 6 minutes as 1 centimeter, then you may be able to represent this, correct? But the problem will be that 1 hour we will have how many? Because 1 hour is 60 minutes, correct? So 10 you have to represent, right? Because 1 hour, let us say 60 minutes, 60 minutes you represent it by how much scales? Suppose I represent with 10 centimeter, 10 centimeter. So 1 minute, 1 minute, or let us say 6 minute, 6 minute, 6 minute I will represent by 1 centimeter. So that you can do it, right? That means 10 divisions you can represent 1 hour, but there are many hours, so the gap may be more larger. So you can choose still a smaller thing. It depends on you, right? So you can choose even uh, 0.5 or 5 centimeter as 6 minute, right? Or you can go for is zero point 0.5 centimeter as 6 minute, or whatever the division suggests, because if it is millimeter you may choose millimeter also. So take a graph sheet and try to plot it. Okay, but this type of graph will happen. And also note that the slopes would be larger while you are representing them. You will be figuring out that this slope will be larger because this is faster, and this slope will be smaller because this is a slower speed, right? So more or less the graph will come like this. But the thing is that this division, this sometimes what happen, if the graph is very lengthy, it is not able to fit, we can represent like a kink. A kink can be used to represent, like for example here you may represent like this kink, like this. A kink can be used to in some cases where the divisions cannot fit inside that. If it is very long, we cannot fit inside that scale, but we can represent like a kink, right? Fine. So this is what the idea is. Now let's go next. Next question. Let us try next question. A drunkard walking narrow lane takes 5 steps forward and 3 steps backward, followed again by 5 steps forward and 3 steps backward, and so on. Each step is 5 meters long and requires 1 second. Plot the graph of his motion. Determine graphically otherwise how long the drunkard takes to fall in a pit 13 meters away. So try to first analyze this motion. What kind of motion will be? So suppose this is a drunkard, right? And he starts. So forward he is taking 5 steps, 5 steps, 5 steps, and backward he is taking 3 steps, 3 steps. So basically, effectively, he is moving how much? 2 steps only in one cycle. 2 steps only he is moving. Correct? 2 steps he is moving. And each step is 1 meter and 1 second each step takes. So that means in total 5 plus 3, 8 seconds, because he has moved 8 steps, he is going to effectively move 2 meter only, right? So like this in one cycle, this is going to happen. Now you think about it analytically. First, let us try to think about it. So he has to go up to 13 meters, right? Where is the pit? Pit is 13 meters, 13-meter distance, right? So he has gone first 5 plus 3 8 meter, but effectively 2 meter only. Then next cycle when he goes, what will happen in the next cycle? Think about it. So that means 2 meter he has moved, then again 5 3, right? Again it will go. So two step, then how much further? 4 only, correct? So again 2 steps it will move further, effectively 2 steps only, 2 steps. So he has moved 2 meter, 2 meter, 4 meter effectively he has moved, but he has gone 5 3 back, then from there he has moved forward. Like this it is happening, right? Okay, then similarly it will continue. So he has to meet where? 30 meters. So just think about it, 2 2 2 2 if it is going, so how much it will go. But note that it is very important to know when he will fall. So when he will fall, while moving forward only he can fall, not that forward, because in the forward motion he will be crossing that 13-meter line. So in the forward motion only he can, it's not that forward he doesn't fall and backward he can fall. That backward situation falling is not possible. So he is going to fall in the forward only. So just think about it, what are the possibilities? You can just think about it like this. Okay, so first he has moved to 2 meter here, right? So 5 meter and 3 meter backward. So effectively 2 meter. Then from 2 meter effectively next cycle it is taking. So from 2 meter, 2 plus 5 it will become 7, right? 7 it will become, and from 7 again 3 step backward. So from 7 3 it has come to 4. Now from 4 again he will go forward. Just think about it. 4 plus 5, 4 plus 5 9 it will come, right? And from 9 3 you subtract, it has become 6, right? From 6 again you add 6 plus 5 11. From 11 again you subtract 3 8 8, and from 8 plus 5 you do, so it has become 13. So that means it is going in the forward step, is falling now. So you can think about how many cycle it has happened. One cycle, two cycle, three cycle, four cycle, four complete cycle has happened, and in the next one forward, right? So how much time it will be, just calculate. So time taken they are asking, right? Time taken, so time is 4 into 4 cycle is there, and in one cycle how much? 8 step means 8 second, 8 second plus one forward, last forward, that means how much? 5 step means 5 seconds. So this is what it is. How much it can come? 32 plus 5 37 seconds. This is the answer, right? Now they have not asked to follow just graph only, but now let us think of graph we can think. Let us try to make using graph. So this is xt graph. We are trying to draw xt graph. In xt graph, what you will do? You will start from here. So some speed will be there. So first it will be going to some 5 step, correct? So that means 5 meter it will go. 5 meter it will go. Then what? It is coming down 3 steps. So next it will come to 2 meter it will come. Okay. So it will be coming at 2 meters here. And note that the slope will be same, because while going forward, while going coming backward, speeds are same, so slope will be same. Here it has come, and then again, so I will write here this point. This is 5 after 3 back, so it has become 2. Then again it will go. Now let us repeat that. So from 2 it will be going how much further? 5. So 7 it will become 7, and from 7 again 3 back, so it will come 4. So slope you maintain proper, it will come somewhere here 4. Again 4 plus 5 9, 9. Again 9 minus 3 6, 6. Again from 6 plus 5 11. Again 11 minus 3 8, again 8 plus 5, 13. So this is where game is over now. His game is over now. Okay, so now tell me how much time. So this one cycle, this was 8, then 8 into 2, 16, 16 into, then plus 8, 24, 24 plus 8, 32, and this extra 5, that is 37. So like that graphically you can plot, but the thing is that this question is given, you can think of something more. Like for example, suppose they say that here you can plot the graph and do the analysis like that, but suppose it is very very far away. Let us say 100-meter pit is there, or 1000-meter pit is there, then how much time it will take? Have you thought any time like this? Think about it. It is a very good question. Very nice question. What can be the approach for such problems? Let me think about it. What can be the approach for such problems? So there must be a mathematical way to solve it, right? And I gave one key idea. The key idea is that it will be falling only in the front, that means forward. The forward journey only he will fall, backward he will not fall. So try to think of the calculation. Suppose if I say that effectively 2 is there, 2 meter, and I have taken 30. So I may think of 6 cycles, right? 6 cycles I will think, and plus 1 I will think, but no, this will not work. Okay, this approach will not, because you need to definitely develop a approach. What is the calculation happening here? So 2 approaches if I do like that, because in one cycle 2 meter, next cycle 2 meter, next cycle 2 meter, like that you think. Suppose if you take 6 cycles, you just think of 6 cycle, and before also and after also you need to think about, right? For example, here how many cycle has happened? 4 cycle has happened. So when you have calculated 6 cycle by thinking that okay, 13 divided by 2 I will do 6, I will get 6 plus something, but you think before also, because the forward approach has to happen, it can happen before 6 cycle also, right? Before 6 cycle also it can happen, because while it is moving forward, then only it is going to fall. So try to think about it. You can definitely make a rule about that. You can make a rule and try to solve that question, right? Then let us move to the next question. Number 5. A jet airplane traveling at the speed of 500 km per hour ejects its products of combustion at the speed of 1500 km per hour relative to the jet plane. What is the speed of the latter with respect to observer on the ground? Let's try to understand this. A jet plane is there. So suppose some plane, I am just rough diagram I am showing, is going at a speed of, it is going at a speed of 500 kilometer per hour. Okay, at the speed of 500 km, ejects its product of combustion at the speed of 1500 relative to the jet. So this gas or ejection, it is coming out. This is, they have given, let us say that this is 1 and this is 2. So they have given velocity of 2 with respect to 1. Okay, and that is given as 1500 kilometer per hour relative to the plane. What is the speed of the latter with respect to observer on the ground? So suppose there is an observer on the ground. So what is the speed of this second object, that is the ejected gas, with respect to ground? Because this is relative speed. You should know that they are going opposite direction, right? So suppose this is the speed of this jet 1, actual speed, and this is the gas speed, because gas is coming down, right? So this is v1 you take, and this is v2 you take. So relative speed, when they have given relative speed, two bodies going in opposite direction, so relative speed is the sum of that. So this is nothing but v1 plus v2. Okay, so v1 is already given 500. So from here 1500 is v1 is 500 plus v2. So from here you can understand that v2 is 1000 kilometer per hour. and of course it is going downward, right? We are taking that it is going downward. So 1000 kilometer per hour you can write. Otherwise you can write with plus minus sign also, you can do the calculation. How? So if they have given this as plus, let us use proper sign plus, then you have to use this as minus. Correct, you have to use it minus. Now here you do not know anything about it. Let us say you don't know its direction, whether it is going up or going down. So let us say for example, you do not know anything about it. You do not know anything about it. But you know V21, right? V21. Now let us write this with proper sign. This we have done without sign, but now let us do this calculation with proper sign. Proper sign. So V21 is minus because relative to this it is going down. So now you write this V21 as V2 minus V1. Now let us substitute with proper values. So this is V1, we know how much it is. V1 we know. V2 minus V1 we know, that is plus 500. Plus 500. So this is minus 1500. So from here you can clearly see that V2 is coming as minus 1000. So now with proper sign it is coming, right? So you can use proper sign convention, or when they are opposite then you can just add their magnitude that way also. But take care of the calculation, because whenever vector quantities are involved you have to be very careful, right? Fine, let us move next. Question number 6. A car moving along a straight highway with a speed of 126 km per hour is brought to a stop within a distance of this. What is the retardation of the car? Assume uniform, and how long does it take for the car to stop? So this is a very classical type of problem, right? Stopping distance, stopping time. So suppose that there is a body, right? It is going car and brakes are applied. Okay, brakes applied, brakes applied. So when brakes are applied, what happen? The ground is going to now stop it. Now it all depends on the ground, how much friction is there. Based on that, it is going to stop it. And there is going to be a constant retardation. Why? Because friction will be acting this way on this, right? Wheels are locked, wheels are not rotating now. So wheels are locked, friction will be sliding, friction is going to act and it is going to stop after some time. Let us say speed becomes 0 after some time, and it's a constant retardation, so you can use v square equal to u square minus 2a x. X is the distance traveled, minus a I am using for retardation, a is the retardation here. So final velocity is going to be 0. So from here this stopping distance formula is u square by 2a. All of you know that, correct? Right? So what are they asking here to calculate? What is the retardation? So that means x a you calculate. A is retardation here. A is equal to u square by 2x. You can do the calculation, right? Speed they have given, right? And you can just do the calculation. Distance also they have given. Speed you need to convert 126 kilometer per hour. You have to convert into meter per second by multiplying 5 by 10. Those calculations you can definitely do that. So acceleration you can do calculate, right? How long does it take for the car or time to stop? So v equal to u plus 80 we can apply. V equal to u minus 80, because acceleration a is retardation here. So from here time will be u by a, right? So once you have calculated acceleration you can calculate this. Clear? So you will be able to do this type of question. Now let us move forward. Next, two trains A and B of length 400 meter each are moving on two parallel tracks with a uniform speed of 72 km per hour in the same direction, with A ahead of B. The driver of B decides to overtake A and accelerate by this. If after 50-second guard of B just brushes past the driver of A, what was the original distance between them? So let us try to think about this question and draw proper diagram to solve it. Two trains A and B of length. I can represent the train with a line, that's all. No need to draw all that. Okay. So each has 400 meter are moving on two parallel tracks with a uniform speed this in the same direction, with A ahead of B. A is ahead of B. So this is a train and this is another train we can take. So this train is A, this train is A, and this train is B. Okay, right? Okay. The driver of B, so right now they have the same speed. What is the speed? 72 kilometer per hour. Convert 5 by 18, so 20 meter per second. So both the trains are going with the same speed of 20 meter per second, right? And their lengths are also same. This length they have given 400 meter, 400 meter. Okay, right? And the driver of B decides to overtake A. Driver of B decides to overtake A and accelerate by 1 meter per second square. If after 50 seconds the guard of B just passes past the driver of A. So first of all, note what is driver and what is guard. So this front part, let us start this as 1 and 2, and this is like right as 3 and 4. Okay, 3 and 4. So this 3, the front part of this is like the driver, the back part is like the guard. Okay, back is guard, front is driver. So there may be some distance between them, but they are saying that this is overcoming. Overcoming means what? After some time, what is happening? Think about it. So that means here this is A, that means this 3 will be here, 4 will be here, and they are saying that driver of B just brushes past the driver of A. Just brushes past the driver of A means what? This, like this. B has come. So this one, 2, and this is 1, right? So just now it is passing by, right? Just now it is crossing that. Okay, if after 50 seconds, so this is a time 0 position you take, and that is time 50 seconds. Okay, then what was the original distance between them? Between what? Here there can be confusion. Distance between what? Again, read this question. The guard of B just brushes past the driver of A. Guard of B, which is 2, and driver of A is 2, 3. 2, 3 distance was what? That is what they are asking. Distance between 2 and 3, original distance between 2 and 3 they are asking, right? Originally how much distance was there? Definitely this distance was something, maybe it is larger than the length, definitely, right? So think about it. Now we can think about it. Calculation now you can do. Of course, relative motion can also be applied, but this way, if you try to do now, some clear, image will come. You can try these approaches. Okay, think about it. We can think about relative motion also afterwards, but try these approaches. Okay, try that. So this distance was something we do not know. Let us say you want, see, whatever you want to find, let us put that as x and then go in that way. Okay, so this distance they were asking, let us say that this is x. Definitely this distance is how much they have given, that 400 meters. So this is 400 meter 400, and this is also 400 meter. What is this distance? We do not know. Correct? This is why we do not know what is y. Y value we do not know. But we know that x is 400 plus 400 plus y. Now think about it that. So in 50 second they have told, right? 50 second, and their speeds are same 20. So how much distance each point will travel? So distance traveled is distance is speed into time. Just multiply speed into time. Okay, so 50 second into 20 you have to multiply. So 3 will come here, 4 will come here, right? 1 will come there. Think about it. huh? So try to plot these distances and think. So 1 will go from here to this point, this one, correct? How much that distance will be? Think about it. So 50 second into 20, how much it is? 1000. That has become 1000 meters. Okay, what else? Now So what can we calculate now? If you can calculate y, then I think we can find out the answer, because 400 plus 400 plus y will be the answer. Can we calculate y? Can we calculate y? Think about it. Think about it. Because see, we can also calculate 300, 3 to 3. 3 to 3 distance is also the same. Correct? Distance moved by that point 3. How much it will be? Because this is okay. Also note that the speeds are different. Okay. So if speed is different, so first this will be 1000 meter, because it is going with a constant speed. This is under acceleration. No. So what will be this distance? So tell me what will be the, as is ut plus half at square, you have to apply. So what is the initial speed? You know, ut plus half at square, apply this one, because this is under acceleration, right? This is overtaking it, correct? So ut plus half at square, u was how much? 20. 20 ut, t is also multiply. So 20 into 50, ut plus half a. Acceleration is how much? Acceleration is how much? 1 half a t square. Time is 50. 50 square you have to do. Now you calculate this is how much? How much is this? You calculate. This is also 1000, and this is 2500. 2500 by 2, correct? So 1250, 1250 plus 1000, 2250, correct? Okay, now you need to find out this y. How can we calculate y? Note that we can do this calculation of y. How? Because from here to here distance you can measure it. How much it is? Just check that. Because this is already 400, this is already 1000, this is already 400, correct? So 400 plus 1000 plus 400, right? This is distance from here, and from 1 to 1, that is 2250. So y you can calculate very easily here. Y will be 2250 minus how much? 400 plus 400, 800. 800 plus 1000, 1800. How much it will come? Calculate this y. So this will come 50, and then here 4, correct? 450, correct? Is this right? Check that. Right. So you got y. Now what you want to calculate? What do you want to calculate? You want to calculate x. So x is nothing but 400 plus y plus 400. That means 800 plus y. So you want to calculate x. Now you got the answer. It will be 800 plus y. Y is how much? 450. 450. So you got the answer x here. How much it is? 1250. Correct? This will be the answer, 1250 in meters. So you can draw the diagram to get some ideas and all that. Now suppose if you want to think by relative motion, how can you think of relative motion? Relative motion can give a better approach. Let us try by relative motion. Let us try this with a relative motion. So this is A and this is B. These points, right, I have taken, this is 1 2, this I have taken previously 3 4. 3 is the front part, 4 is the back part. Right now they have same speed initially, right? Now this start under acceleration, so you can study relative to because this is going to cross, this point 2 is going to cross 3. So let us say there is an observer here, there is a observer here. This observer is going to just see point 2, right? Point 2. and point 2 is right now some distance away. As I told, this is why you do not know this distance, but this distance total, right now the total distance 2 to 3, that is 400 plus 400, 800 plus y. This is what you want to calculate, right? This is what you want to calculate. Now this is under acceleration, and relative motion you have to consider. So initially, with respect to this observer, it will be starting with zero speed, because initially they have same speed, same velocity, same direction. So relative, when you see, so relative velocity is zero. So let us write u is going to be zero. I am writing about relative motion. Relative motion of what? Point 2. Point 2 with respect to 3. If you want, you can write 2 with respect to 3. 2 3. So relative velocity of initial velocity of u with respect to 3 is 0. Now it is going to come there, and that point 2 has to come to point 3, right? How much time it is taking? Time taken is 50 seconds. Time taken is 50 seconds. And what about acceleration of 2 with respect to 3? Acceleration is 1 only, because this is not accelerating, only that is accelerating. So relative acceleration is nothing but acceleration of 2 minus acceleration of 3, but 3 acceleration is 0, so only acceleration 2 will come, right? These are the things you know, right? So can we calculate now? So we know acceleration, initial velocity we know. Then can we use s is ut plus half at square and all that? Can we use? Yes, we can use that. S is ut plus half at square. So relative distance that it has to travel is x only. So x is equal to ut 0 plus half at square. A is 1 into t square. T square I'll do. So how much do we get from here? 2500 by 2. So you can see in one step we got the answer, 1250 meters. Now which is better? For competitive exam, of course this is better. You can just think of relative motion solving, but that previous step was of course a long method. But initially, when you are trying to build up your knowledge, build up your understanding, you can definitely go with that. Here my goal is to give you all kind of approaches which will be useful for broader view, right? Then let us move next. Question number 8. On a two-lane road, car A is traveling with a speed of 36 km per hour. Two cars B and C approach car A in opposite direction with a speed of this each. At a certain instant, when the distance AB is equal to AC, both being 1 kilometer, B decides to overtake A before C does. What minimum acceleration of car B required to avoid an accident? So again, try to just get a mental picture of that. What is happening here? Okay, on a two-lane road. Two-lane road means there will be road like the parallel, you can say. Car is traveling with a speed. So suppose this is, I'm representing this with a point. Okay, it is going with a speed 36 kilometer per hour. Okay, I can choose to convert into SI units. So 5 by 18 we will do. So 10 meter per second it is going, right? Okay. Two cars B and C approach car A in opposite direction with speeds this each. At a certain instant, when the distance between A B is equal to AC, A to B, let us say B is here and C is here. Okay, so this distance of A from B and A from C, they are both equal. Okay, let us do that here A is like this, same distance they are. Okay, equal distance, both being 1 kilometer. So this distance is also given. This is B, right? This is B. This distance is 1 kilometer. This distance is also 1 kilometer. Okay, but they are moving in opposite direction. So this and C, they are moving in opposite direction. So B is moving this way, C is moving this way. Okay, B decides to overtake A before C does. What minimum acceleration of car B is required to avoid an accident? Now here in this question, We need to also be sure, like, where is B? B is this side or that side? Is B going in the direction of A, or B is going opposite of A? Where it is? Let us think about it. Again, read the question. Two cars B and C approach car A in opposite direction with a speed of this. B and C are approaching car A in opposite direction. So is it that B is that side? Yes. Distance of AB is equal to AC. Both being 1 kilometer, B decides to overtake A before C does. What minimum acceleration car B required to avoid an accident? Car B and C approach car A in opposite directions. Right? What it means? This statement only we need to understand properly. Two cars B and C approach car A, they are approaching car A in opposite directions. So we are taking that B and C are approaching in opposite direction. Okay, is this interpretation correct? Because you need to start with some interpretation, because things are not clearly given, figures are not given. You have to start with something. So if A is going like this way, I am taking B is behind it and C is in front of A, and they are approaching opposite of each other, right, like this. And what is the speed they are going? 54 kilometer per hour. So again, 5 by 18 you do, 18 into 3, 3 into 5, 15, right? So 15, it is going with 15 meter per second. This is also moving with 15 meter per second. Okay, then what minimum acceleration car B is required to avoid an accident? B decides to overtake A before C. So before C will reach here, B has to reach here, or you can say almost same time they reaches here. Okay, so but it's what is that time? I think they are asking what minimum acceleration B is required to avoid. What minimum acceleration B should have? Okay, so first of all, you should know that how much time C will come here, how much time C will come here, because distance is given, so that time we can calculate first, because relative motion they are going in opposite direction. So let us calculate that time when C will meet A. C will meet A. How much time? Time is distance by speed. Distance is how much? 1 kilometer. I am taking as 1000 by this speed in opposite direction. So 10 plus 15, 25, 25. So from here you got this as 40 seconds. So C will reach A in 40 seconds. Definitely it will meet at this 40 seconds. So it has to reach before itself, right? So the time B should take should be less than 40 seconds, not exactly 40, less than 40. So it has to accelerate, so first try to think about it, how much time it will take. Okay, how much time it goes with some acceleration, and it has to cover this distance. So we can use the formula S is ut plus half it square. Can we use? Try. As distance is 1 kilometer, so 1000 ut initial speed 15, if ut plus half at square, acceleration we have to calculate t square. Now here we can substitute time as 40 second and then try to calculate this. Okay, try to calculate this, how much it will come. So 1000 minus 15 into 40 is equal to half a 40 square. How much do we get from here? 15 into 4, 600, so that become 400. That become 400 here, right? 400 here, 40 into 40. So okay, let's start this. 400 is equal to a by 2 into 40 into 40 means 1600, correct? 1600. So from here, if you cancel out this 400 4 times, and You can cancel this with 2. So acceleration will come as 1 by 2, 0.5. 0.5 meter per second square. Note that by making all such assumptions, we are deriving this. Okay. Right. So acceleration is equal to 0.5. This is the minimum acceleration. Note that minimum acceleration, because he can accelerate furthermore, then he can reach even in less time. Okay. But this is the minimum acceleration because we have taken the same time to reach, just to avoid accident. Fine. So this way we can solve it. Let us move next. Question number 9. Two towns A and B are connected by regular bus service with a bus leaving in either direction every 10 minutes. A man cycling with a speed of 20 km per hour in the direction A to B notices that a bus goes past him every 18 minutes in the direction of his motion and every 6 minutes in the opposite direction. What is the period T of the bus service and with what speed assumed constant do the bus? This question of NCERT has come last year. Last year, they have asked this question in NEET. And it is like a toughest question because the paper was a tough paper. And this question exactly similar format, their only values might be different. So they have given this question. So NCERT, not only in NEET but as well as in J, they can give questions from NCERT because NCERT is a very good book. People generally are ignoring it, right? And a lot of problems are also at advanced level if you take particularly the old NCERT books. So here I have kept many other questions from old NCERT also. We will be discussing everything, right? So let us try this question. So two towns are there, A and B, connected by bus service. They are saying that every buses are leaving from A to B or B to A at the direction every 10 minutes. Every 10 minutes it is leaving. Try to draw that diagram. Some rough idea we can get. Draw the diagram. So this is town A, this is town B, and here buses are leaving A to B. Similarly, here also buses are leaving from B to A, right? Every T minutes. Okay. And they are saying that a man cycling with a speed of 20 km in the direction of A to B notices a bus going past him every 18 minutes in the direction of his motion. So suppose that there is a person who is bicycling, right? So person is going by bicycle like that. Okay. So just think about it. So he is going with a bicycle with some speed, they have given 20 kilometer per hour. 20 kilometer per hour. Okay, we can convert into per minutes also if you want, because here minutes. Okay, we'll convert it afterwards. First let us write 20 kilometer per hour is going. Okay, right, direction of A to B, that a bus goes past him every 18 minutes in the direction of his motion. So what he figures out is that buses are going every how much how much time? A to B buses going through him, past him every 18 minutes. 18 minutes. 18 minutes. Every 18 minutes. And in this direction also he is seeing buses, right? Every 6 minutes opposite. So every 6 minutes he is feeling. Every 6 minutes he is feeling opposite buses are going, right? Okay. What is the period T of bus service and with what speed constant the buses ply on the road? Okay. Let us say that the speed of the buses is VV, or same speed they are, right? We are also saying that regular bus service leaving, right, same speed it is going. So this speed is, let us say, V, and this also speed is V. Both speeds are VV. Okay. So think about it. How are you going to solve this problem? Here, no, people will do something to solve, but clarity should be there, man. Clarity. If clarity is not there, na any formula blindly you can think and apply, you can get the answer, but clarity will not be there. And if clarity is not there, you will get stuck afterwards. Not now, afterwards you'll get stuck. So let us make things very clear, ultra clear. Think about it. So that means this time every 18 minutes, every 6 minutes is with respect to that bicyclist, right? person who is driving the cycle. That person himself is going 20 kilometer per hour. Okay, so think about it. That person who is going with 20 kilometer per hour, you can keep the person anywhere in middle. Anywhere you can keep this person. Okay, either you can keep here or here. Anywhere you can keep. Okay, so let us say that the buses which are coming from behind, so what he will see, that person what he will see, the bus's relative speed. Now let us say, so the bus which is going in the same direction, let us say speed in kilometer per hour, so this he will see as v minus 20, and the buses which are coming in opposite to him, that will give, add, right, add this speed, so that will be v plus 20, v plus 20. So this person will see that the buses which are coming from behind, that means from A to B, that is coming as V minus 20, and which is coming from front B to A, that is coming as V plus 20. Right. So he's seeing, and you may choose some distance. It doesn't matter. You can choose some distance if you want, right? Some distances you can choose. So, but whatever distance you have to choose, you have to choose same distance. Let us consider that it is some distance x from here and some distance x from here, right? So relative to that, now you try to calculate how much will be this time they have given, right? Time, that 18 minutes you convert in hour. So that time which they have given, uh, you can also write this distance x, relative distance. X is equal to, distance is speed into time, speed is v minus 20, v minus 20 into that time. Time I will write as 18 minutes. Minutes you can convert divided by 16, and this x is also going to be what? From opposite direction. V plus 20, right, multiplied with time. That time is how much? 6 minutes. So 6 minutes means 6 by 60. So now try to just solve these two equations. What do you get? Definitely you will get speed v, correct? So 60 will get cancelled, and 6 will get cancelled with 3 here. So v plus 20 is equal to 3v minus 60, correct? So 3v minus v, 2v, 2v will give how much from here? This has become minus 60, minus 60. 60 will go this side, it will become 80, correct? So what will be v? V will become 40 kilometer per hour. That will be the answer. Kilometer per hour, right? Like this, 40 kilometer per hour will be the speed. Now the question is, what is the time period? What is the period of the bus service, and with what speed? Speed we have calculated. Period means every minute how much, right? That time only they are asking. Every minute how much it is. How will you calculate that? Every minute. So can we now calculate x from here? X was the distance, right? So from here he is able to find out buses coming every minute. So how much is that distance? Can you calculate? Now we can calculate here. What will be that? Suppose if I substitute there. So what will be x now? X I can calculate. How much will be x? Because x is 6 by 60 means 1 by 10. 1 by 10 it will come, and this is 40. 40 plus 2, 60. Correct? So 60, 60 by 10 means 6. That is 6 what? Kilometer. Right? This is 6 is in kilometers. Because this I have taken in terms of kilometer per hour. Correct? Okay. Then what do we want to calculate here? What do you want to calculate? What is the period t of the bus service with t means what? Per minute. Per minute. Per minute. Every t minutes buses are coming. So note here that this buses which was coming is like one bus in this much time. Similarly here this much buses were coming, right? Every 6 minutes buses were coming. So x distance was being covered with this speed. So how do we calculate that? Suppose this distance x was covered by this speed. So how much was the speed with which this will be covering this? That distance x was actually covered by the bus only, right? So can we calculate that? How much time? How much actual time it will be? That time you calculate at distance 6 by speed. Speed was how much? 40 kilometer per hour. So 40. Now this is in hour. Hour you can multiply in minutes you want. So hour means you have to multiply with 60. So now you check this how much. How much it will be? It will become 36 by 4. That means 9 minutes. 9 minutes. Yes. So every 9 minutes, buses will be going from either this side to that side or that side to this side. So this is the approach. What is the approach? You should also calculate that text, because based on that only you will be calculating. Some people are just doing some random thing. Things will not be clear if you go like that. Okay, so you have to be clearly. The steps are very small, not big calculations are there, but you need to understand how to do the calculations. Some rough ideas, some diagrams should make things clear. Otherwise blindly you won't understand things. Okay, let us move next. A player throws a ball upwards with an initial speed of this. What is the direction of acceleration during the upward motion of the ball? So note that a person has thrown the ball. Acceleration due to gravity is always downward. Always downward. It's not that acceleration will change because you have thrown upward. You might throw in any direction, doesn't matter. Earth will always pull it downward. So acceleration due to gravity is always, what is the direction of acceleration they are asking? That is already known. Acceleration is always acting downward, which is value g, right? So upward moves, ball may move upward or ball may move downward. It does not matter, right? Motion of the ball does not matter, but acceleration is always downward. Suppose if it is moving upward, then its speed is going to decrease because of retardation. And if it is moving downward, then it is under acceleration. So acceleration means speed is increasing because it is moving in the direction of acceleration. And if the body moves, or that means velocity is opposite of acceleration, then it is under retardation. Okay. So what are the velocities and acceleration of the ball at the highest point of it? See, they are asking at the highest point. Highest point it will stop. Highest point velocity is going to be 0. Right? But acceleration will always act downward. Acceleration is always acting downward. Velocity has become 0. Choose the x equal to 0 meter and time 0 second to be location, and time the ball at its highest point vertically downward direction to be positive direction. Okay, and give the sign of position. So vertically downward, let us choose vertically downward direction as positive. And original topmost position is origin. Choose x is equal to 0, time 0 and location, and time the ball at highest point. So highest point you choose this time 0 position, time is 0 and position is 0, and downward is positive direction you choose. They are giving the sign convention, according to that you have to tell answer. Okay, vertically downward to be positive direction, right? Give the signs of position, velocity, acceleration of ball during its upward and down. So while it is moving upward, so upward means, let us say ball is moving upward, so velocity is positive, acceleration is always negative, acceleration is always negative, right? Acceleration is always negative, and you are thrown from ground, right? So body is in downward direction only, means position is below only, so x position is also negative. So position is negative. And what about velocity? Body is moving upward, right? So during upward motion velocity is still negative, position is also negative. So position and velocity are negative, but acceleration is, downward direction is positive, right? So acceleration is positive, okay. Then, so this is for upward motion. What about downward motion? When the body is moving downward motion, so x is positive, velocity is positive, Acceleration anyway is positive. Acceleration is always positive. So we know that already. Then next, to what height does the ball rise and after how long does the ball return to the player's hand? To what height does, so what is the speed with which it is thrown? They have given, initial speed, right? That. To what height does the ball? So direct formula, let us apply that. So if we are throwing it with a speed u, so to what height it will go? Height we can apply like stopping distance. So u square by 2g we can apply. Calculation you can do because here u is given, g you have to take as 9.8 if not given. Right? How much is u given? U is given 29.4. 29.4 meter per second. So you can substitute and calculate the maximum height. What else they are asking? After how long does the ball return? Total time of flight they are asking. So total time, first of all, it will go up and it will come down. So total time is 2u by g. So just substitute and calculate. Simple questions, right? So I hope you are understanding, right? Basic calculations, how to do.